Good day everyone, I am Cristina Generalao and I am your teacher for today's discussion.
Finding roots of a quadratic equation. What is a quadratic equation? A quadratic equation is in the form of ax squared plus bx plus c equals 0, where a, b, and c can have any value except that a can't be 0 and x is the variable or unknown since we don't. Finding roots of a quadratic equation. There are three ways to find the solutions or roots of the function. First, we can factor the quadratic equation. Second, we can complete the square. Or third, we can use the special quadratic formula, which is x is equals to negative b positive negative square root of b squared minus 4ac all over 2a. Factoring quadratic equation. There are steps in factoring a quadratic equation. First, get the product of a and c and copy b. Second, rewrite the middle term with those numbers in step 1. Step 3. Factor the first two and last two terms separately. Step 4. If we've done this correctly, our two new terms should have a clearly visible common factor. Examples. First, factor x squared minus 3x minus 4 is equals 0, and its coefficients are a equals 1, b equals negative 3, and c is equals negative 4. Here's the solution. For step 1, we're told to get the product of AC and copy the value of b. So, AC is equals to negative 4 since A is equals to 1 and C is equals to negative 4 and B is equals to negative 3. Step 2, we need to write the second term, which is negative 3x, using the numbers in step 1. So it must be x and negative 4x. So for the step 2, we have x squared plus x minus 4x minus 4 is equals to 0. Step 3, we need to factor the first two terms and the last two terms separately. So, x squared plus x has the factor of x times the quantity of x plus 1, and negative 4x minus 4 has the factor of negative 4 times the quantity of x plus 1. So, for the step 4, we have x plus 1 as common to both terms. Thus, x plus 1 and x minus 4 are the factors. To check if we are right, we just simply multiply x plus 1 and x minus 4. So, x times the quantity of x plus 1 minus 4 times the quantity of x plus 1 is equals to x squared plus x minus 4x minus 4. And thus, it is equal to x squared minus 3x minus 4. Second example is 2x squared plus 7x plus 3 is equals to 0, where the coefficients are a equals 2, b equals 7, and c equals 3. For the solution, step 1, we must get the product of a, c, and copy b. So 2 times 3 is equals 6 and b equals 7. Step 2 is we must rewrite 7 in terms of our numbers in step 1. So it must be 2x squared plus x plus 6x plus 7 is equals to 0. And step 3, we must factor the first two terms and the last two terms separately. So the factors of 2x squared plus x is equals to x and 2x plus 1, while the factors of 6x plus 7 is equals to 3 and 2x plus 1. So, as we see, we have 2x plus 1 as a common factor. It serves as our answer for the step 4. Thus, the factors are x plus 3 and 2x plus 1. To check if we got it right, let's try to multiply x plus 3 and 2x plus 1 if it will be equal to 2x squared plus 7x plus 3. So, x times 2x plus 1 plus 3 times 2x plus 1 is equal to 2x squared plus xx plus x plus 3. And combining similar terms, we have 2x squared plus 7x plus 3. So, we are right. Second way to find the roots of a quadratic equation is by completing the square. And completing the square, we're going to take the quadratic equation ax squared plus bx plus c and turn it into a times the quantity of x plus d squared plus e equals 0, where d is the quotient of b and 2 squared and e is equals to c minus d. Then, the roots are in the form of quantity of x plus d squared plus e. There are 5 steps in completing the square. Step 1. Divide all terms by a. Step 2. Move the number term c over a to the right side of the equation. Step 3. Complete the square on the left side of the equation and balance this by adding the same value to the right side of the equation. Step 4. Take the square root on both sides of the equation. And step 5, subtract the number that remains on the left side of the equation to find x. For example, complete the square of the following equations. First, x squared plus 6x plus 7 equals 0, where a is equals 1, b is equals 6, and c is equals 7. So for the solution, we must transform x squared plus 6x plus 7 into quantity of x plus d squared plus e. But we must find the value of d and e first. So, since d is equals to b over 2 squared, our d must be 6 over 2 squared. And 6 over 2 is 3, and 3 squared is equals to 9. So, d is equals to 9. And for the value of e is equals to c minus d. Since that our c is 7 and our d is 9, so a must be 7 minus 9. So the value of our e must be negative 2. Now, we're going to substitute the value of d and e for us to complete the square. So, quantity of x plus 3, which is the value of our d squared, minus 2, which is the value of our e, is equals to 0. Thus, x squared plus 6x plus 7 is equals to quantity of x plus 3 squared minus 2. Our second example is 5x squared plus 4x minus 2 is equals to 0. And the coefficients are a equals 5, b equals 4, and c equals negative 2. For us to deal with the equation easily, we must divide both sides by 5 so that we will have x squared plus 28x minus 4 is equals to 0. And now, we will find the value of d and e. Since d is equals to b over 2 squared and the value of our b now is 28, d is equals 28 over 2 squared. So, d is equals to 16. And e is equals to c minus d. So, e is equals to 0.4 minus 0.16. So, the value of our e is negative 0.12. So, we have the equation now x squared plus 28x plus d equals to 0.4 minus e. Now we just substitute our value of d and e. So, x squared plus 0.8x plus 0.16 is equals to 0.4 minus 0.16. And we need to factor the left side so that we can have the roots. So, factor of x squared plus 0.8x plus 0.16 is just equals to quantity of x plus 0.4 squared is equals to negative 0.12. So, 5x squared plus 4x minus 2 is just equals to quantity of x plus 0.4 squared minus 12. Third way to find the root of a quadratic equation is by using the quadratic formula. A quadratic formula is x is equals to negative b, positive and negative, square root of b squared minus 4ac over 2a, where square root of b squared minus 4ac is called the discriminant. Note that when the discriminant is positive, we get two real solutions. When the discriminant is 0, we get just one real solution. And when it is negative, we get two complex solutions. For examples, find the roots of the equations by using the quadratic formula. First, solve 5x squared plus 6x plus 1 equals 0, where a is equals 1, b is equals 6, and c is equals 1. Solution. Using the quadratic formula, x equals to negative b, positive and negative square root of b squared minus 4ac all over 2a, we just simply substitute the value of a, b, and c. So x is equals negative 6 as the value of b, positive negative 6 squared minus 4 times 5 times 1 as the value of our b, a, and c, all over 2 times 5 as 5 as the value of a. So, x is equals to negative 6 positive and negative square root of 36 minus 20 all over 10. Then, x is equals to negative 6 positive and negative square root of 16 all over 10. Then, x is equals to negative 6 positive and negative 4 all over 10. Thus, x is equals to negative 2 or x is equals to negative 1. Our second example is negative 3x squared plus 7x minus 35 equals 0. And the coefficients are a equals negative 3, b equals 7, and c equals negative 35. So using quadratic formula, negative b positive negative square root of b squared minus 4ac all over 2a, we need to find the roots of the equation. So, by just simply substituting the values of a, b, and c to the formula, we have x equals negative 7 positive negative square root of 7 squared minus 4 times negative 3 times negative 35 all over 2 times negative 3. So we have x is equals to negative 7 positive negative square root of 49 minus 420 all over negative 6. And x is equals to negative 7 positive and negative square root of negative 371 all over negative 6. Since that negative 371 is not factorable by any perfect square number, we have our final answer. Thus, x is equals to negative 7 positive negative square root of negative 371 all over negative 6. Third example, solve 5x squared plus 2x plus 1 using quadratic formula where a is equals 5, b is equals 2, and c is equals 1. Solution. X is equals to negative b positive and negative square root of b squared minus 4ac all over 2a. So we must simply substitute the value of a, b, and c. It must be x is equals to negative 2 positive and negative square root of 2 squared minus 4 times 5 minus 1 all over 2 times 5. So, x is equals to negative 2, positive and negative, square root of 4 over 20 all over 10. Then, it implies that x is equals to negative 2, positive and negative, square root of negative 16 over 10. Note that our determinant is negative, so it must have an imaginary root. Therefore, x is equals to negative 2, positive and negative 4i over 10. Thus, x is equals to negative 0.2, positive and negative 0.4i.